Good morning, everyone here. Thank you very much for having me this morning. I come from Calgary, Canada, so quite a ways from here. You can see from the photo, there's snow on the ground there. That's my natural environment, but thank you for inviting me here. Thank you for organizing my safe travel. It's a pleasure to be here today. I want to say before we get started that my intention behind visiting here and speaking with you is to be a resource for this group throughout the remainder of the next 2 days. If you do have questions about anything that I present, or you have questions about well decommissioning, site restoration that I can help with, I want to be that help for this team. So I am here to speak today about best practices for decommissioning, abandonment, and environmental restoration in remote areas. And I'm going to go through what we call an accelerated site closure model, which I think this audience will appreciate. Just a little bit about myself before we get too far into it. My name is Adam Derry. I'm a professional engineer, petroleum engineer, trained in mechanical engineering, but have transitioned. I've been with my current company for 14 years in my current role. Myself and my team specialize in well abandonment, decommissioning, and site restoration, particularly in remote areas and in First Nations land, on First Nations land. Can go on a little bit more about our team. So 360 Engineering and Environmental Consulting is the company that I represent. We have executed projects in 11 different jurisdictions in North America and South America combined. Our team has abandoned around 6,500 sites collectively. I would say that we are the largest consulting firm of our type in North America doing this type of work. I thought we would start today level setting with this group to understand what it means to go through the full closure cycle of an oil and gas site. And from there, we can build upon that grounding of knowledge to look at additional components of the closure model. So when we talk about decommissioning, abandonment, and restoration, what we're referring to is these 5 steps that I've outlined on this slide. Well abandonment, facility abandonment, pipeline abandonment, remediation, and reclamation. When we think about each of those in their own project scope, we're talking about with well abandonment, 4 different technical elements that we're trying to accomplish with those operations. So one is to protect subsurface resources from contamination inside the well. The second is to protect groundwater that is naturally in contact with the well due to the well being there. The third is to prevent a release of hydrocarbon to surface at any given time in the future. And the fourth is to remove the surface infrastructure of the well, so the wellhead being removed. Facility abandonment is one of the next phases of that process. That includes purging and cleaning of above ground equipment, dismantling of that equipment, and rendering it in a state where it cannot be repurposed in the future. And hauling obviously all of that equipment off-site to scrapyards or metal recyclers. Pipeline abandonment, somewhat similar in that the pipeline must be first cleaned and displaced to an inert fluid. Then it can be dismantled and removed. Remediation is the second last step in the process. Involves delineation of contaminated soils on site, understanding what needs to be remediated first, and then replacing those soils with natural soil that no longer is contaminated and allows for revegetation of the site. Reclamation, the last process in the cycle, is recontouring the land back to its natural state so that natural forestation can happen, natural vegetation can happen again. So for this group, I wanted to propose that closing sites is possible, and it's possible to do it quickly. It's possible to have an accelerated program. And the reason I say that is because we've been fortunate to have worked with hundreds of oil and gas companies in North America to do exactly that. We know it's possible. It's because we've been involved in teams that have done it. We've assisted oil and gas operators in doing it, so we know that it is possible. When we talk about the accelerated site closure model, the benefits are closing sites faster, reducing costs of those closure activities, which is an important consideration, retention of cost certainty throughout the entire process, improved quality control, and incorporation of continuous improvement. So along with this proposed approach of accelerated site restoration, asset retirement, there are three categories I'm going to discuss with this team today. And maybe I'll mention, I will have a little bit of time at the end for questions. Closer, okay. I will have time at the end for questions, but we'll go through this at a rather high level. So if there are technical questions, I can certainly be of value at the end of this to speak to those. So the three-phased approach is assessment, strategy, and execution. I think it's all too often that us as thanks, Brad. I'm going to hold this now so I don't forget. So all too often we focus on the execution of closure projects, but we forget about the elements of planning that go into making that execution successful. In the accelerated site closure model, we propose assessment, which includes a thorough and in-depth, a deep understanding of the asset list that is being decommissioned, a strategy put in place that accomplishes key objectives, and then execution. And execution being the last phase, in that it is really a byproduct of the planning phases of the model. So we'll start by talking about assessment. Without a clear understanding of exactly what the problem is, and to start as a baseline, there is really no way to determine if success is happening. I've gone through 4 steps here on the slides to talk a little bit about those key elements of assessment that I'm speaking about. The first being confirmation of asset lists. What that really means is taking a inventory of all wells, pipeline facilities, and other sites that require closure. Believe it or not, this is often one of the most challenging steps in an asset retirement program. Step 2 is creating asset types. What this means is grouping those different types into categorically different project types, which is important for the next step in characterization. Characterization is cataloging common elements of closure cycle steps, which then funnels into calculation of obligations. There's a function of time and unit rates, just gets a little technical. Cost ends up being consequential to this process if these first 3 steps are completed. So I'll spend a little bit more time on strategy. We talked about assessment of understanding what needs to be accomplished to close out sites. The next step is completing a full strategy. So the next step in this 3-phase process is the strategy phase. Really what this is about is determining what success truly looks like. Success looks very different for different stakeholders in the program. That includes First Nations, public, the government. Incorporating all elements of stakeholder needs into a program is critical for success. When we discuss First Nations engagement and stakeholder needs, often there are opportunities for sourcing local vendors, local contractors to assist in the work. There's often also opportunities to employ local residents in the project. But one key element of stakeholder engagement that our team has certainly learned over time is that it's best to leave assumptions aside prior to engaging with these groups and simply ask what it is that they need the project to deliver for them. Only when we ask can we really understand what's important, and then we can incorporate those key elements into the project to ensure that everyone at the end of the program is made whole. So the next step in the strategy is decommissioning and restoration plans. Again, this looks at independent or individual project scopes and building an execution strategy for each one of those scopes. We use things like operational decision trees and incorporation of best practices, which are guidance documentation that's available through industry organizations. These all ensure that the projects have the full backing of an operational plan to be successful. Additionally, in the strategy phase, resourcing is extremely important. There's considerations for repurposing of construction equipment to eliminate mobilization of new equipment to the site, which can incorporate, it can be existing servicing equipment, it can be even production equipment that can be repurposed. We also look at workforce development and redeployment, retraining of people with existing skill sets to then be involved in the project and be mutual shareholders and beneficiaries of the project. The last step in strategy is really addressing blind spots and assigning work schedules that allow for those gaps to be addressed in the execution phase. So in this proposed model, the predetermined output of the assessment and strategy phase is streamlined and efficient execution. It's a predetermined result of the other elements that have gone into the project. This allows for these three elements to be focused on during execution: quality control, real-time data reporting, and data quality. One of the most overlooked elements of decommissioning in our current era is a focus on quality standards. The reason this is so important is because once a site is decommissioned, it is extremely inefficient to go back to that site to repair a deficiency. So quality control being at the forefront of the execution phase is imperative. Standardizing processes, leveraging new technology, of which there is a lot of. There are new formulas for cement. There are new formulas for different geophysical logs that we can perform to improve the quality. These all need to be leveraged effectively to create an efficient execution phase. And then implementing an audit process of those quality controls. Real-time data, daily reporting, reliable communication infrastructure, all critical elements as well, especially in remote areas. It can be a real challenge to get communication to the correct people efficiently. And then that data quality. The reason that data quality is so important is because in this proposed model, it allows for continuous improvement. That data can be pushed back into the assessment phase to refine the strategy, and that's how the cycle completes. So that continuous improvement cycle, as I've spoken to, it really does lead to accelerated site closure. Again, I can't emphasize that enough that this is a product of learnings that we have had by working with other oil and gas producers that have effectively managed their liability, their environmental liability. The field data gaps identified during that assessment phase are incorporated into the strategy that allows for the assessment model to be continually refined through execution. The result being the realization of that accelerated plan.